Read exercise number 1. The assignment was to implement part of the bank system following given the UML diagram, on which we can see that system has two classes, class account and class customer. It also lists all of the members of the both classes. In the upper section, all of the properties or fields of the class will be mentioned, and in the lower section, all of the constructors and methods of the class. Plus or minus is an access identifier of the member, and it tells whether the member is private or public. Next is the name of the member, and here, because the name starts with a capital letter, we can see it's a property and not a field. After the colon, the type of the property is mentioned. Here, if it's a method, in the round brackets, we'll see if it expects any arguments, and if it does, then there will be a name and type of the argument it expects. If it has a return type, it will be mentioned in the end after the colon. In the case with the public method withdraw, return type is a Boolean. If a member is public, it means that it can be accessed by the instances of this class and instances of the other classes. If member is private, it means that it can be accessed only by the instances of this class. First, I implemented all of the members of both classes, and afterwards wrote code for bodies of each method. In the class customer, first method is a public method customer. If method has the same name as a class, it means it's a constructor of the class. If it's a constructor, it doesn't have a return type. In this case, it takes 4 arguments. They will be given to a method when the class instance is created. These values will be the new values of the local variables. When the instance of the class is created, first thing we do is assigning new value to a local variable customer ID. For that, we're creating new variable integer customer ID and assigning it a random value, and that value will assign to a local variable customer ID. Sign update according to the latest update of the requirements should be passed to the constructor as well with the rest of the arguments. Name, email, and DOB arguments are as well assigned as new values to the local variables. In the console write line, we're printing out them to see if new values were assigned correctly. Next method called info, and this method prints out the information on the current instance of the class customer. Here we check once again if the current values assigned to local variables correctly. Customer ID will be automatically generated every time for a new customer. So here we can see if this customer ID is unique to him. If a customer has any accounts, this method will list all of them. We'll see the implementation of list accounts a bit later. It's one of the members of class customer as well. Next method is method create account. Here we're creating an instance of another class. We have a class account. We name it A. Constructor of class account expects one argument, customer ID, that is passed here. Customer ID is a local variable for class customer. After we created an instance of the class account, we add it to local member list accounts with the method add, and then test which index current instance of class account has in the list. Every time we run method create account, it will create new instance of the class account and add it to a local list. When we run a constructor of the class account, it assigns new value to a local variable account ID. We use quit for this, converted to string, because local variable account ID is of type string. And later we testing if what ID it received and if it received a unique ID. We also test local variables balance and testing argument that was passed to a constructor account, integer customer ID, if it was passed correctly, and if instance of the customer class has the same customer ID as the customer ID that was passed to account constructor. Next method is deposit to account. It finds a specific account in the list accounts by using integer account index that the method receives as one of its arguments, as well as the specific amount stored in the decimal amount. To run this within this method, we run method deposit, which is one of the members of the class account. After we found specific instance of a class account in the list account, we run method deposit, which checks local to class account variable balance and adds to it the amount which we received as an argument in the method deposit. So basically, method overrides the local variable balance by adding amount of a deposit to it. Later we can see it when we test it in the console write line. And back to the customer. Next method is withdraw from account. It runs in a similar way. It calls it finds the correct instance in the of the class account in the list account and runs local to class account method withdraw by passing it decimal amount. Method withdraw returns a boolean. It returns false if amount is larger than the current balance or balance of the current instance of the customer. If it's not larger, it will override local variable balance to a new value, which will be a balance minus the amount decimal that we received as an argument with the method withdraw, in the method withdraw. And in this case, it will return true. Next method in the member of the class customer is list account. This method will run for each member or each instance of the class account in the list accounts. Method info is one of the members of the class account. It prints the information about the local about the account, its local variables, account ID, and balance. Next method is list account. This method will use the same method info from the class account, but for a specific account from the list of accounts. We will find it by using argument that we pass to a method list account, integer account index. We'll use it by pointing at which position is the account that we want to use method info on. And now we can move on to testing. To test the program I first created in a customer with the name, email, date of birth, and a specific date of birth and a specific sign-up date. Then I will create 3 accounts for this customer for testing purposes. Then I will deposit to account with the index 0, deposit to all of them, basically by targeting them with their index. Then withdraw from the account with index 1, which is second created account, and list the account that we just withdrawn from to see the result of the withdraw method, and see that the list account works properly and can print out the list, can print out the specific account from the list account. Next, this customer will run method list accounts, which will print all of the customer accounts. Then we'll test method info, which will print out all of the information about the customer and list all of its accounts. Then we'll do the same with another instance of the class customer to test whether the ID will be unique, and we'll create with this customer also 3 accounts to see whether each account will receive its unique account ID. Receive the same procedures to test the deposit method, withdraw, list accounts, list account, and info. Okay. As we can see, first method of first line creates a new instance of the customer with the correct values and generated random unique ID, passed values as a name, email, date of birth, and sign up date is the past value as well. Next method is to next method we triggered was to create new account. We can see that this account received an ID, and the next account we will create has a different unique ID. We're printing out also for testing purposes and for convenience to know which index specific account has in the list of accounts. we're printing out account index or reference ID for each of them. Later, when we will deposit, it will be or withdraw, it will be helpful. After we created the accounts, we can deposit, and we can test that when we deposit and aim the account by its index in the list, it deposits to the right account with the right account ID. In this case, account with the reference ID 0 got new balance of 500 crowns, and we can compare to this account, newly created account with the reference ID 0. It has the same unique account ID as the one we deposited into. We can see the unique IDs working, balance being saved properly once again when we withdraw. Account information works as well. We found the account with the index in the list of 1. It has the same ID as it prints out here when we deposit to the same account with the reference ID of 1. We can see this information being stored properly again when we use method account list account, which prints out the information about all 3 accounts. Again, where we can see the reference IDs and balance all stored appropriately. Next, we're printing out customer information, or we trigger method customer information, which prints all of the current customer instance information and all of its customers accounts. As we can see, once again, they're all saved. The balance is saved correctly as well. When we create new customer, it saves new values to local variables and generates unique customer ID. When we look through the test results for this customer and new accounts created, we can see the same consistency of data. Every account has its unique account ID. Balance is set and saved correctly. Thank you for your time and attention.